Hello, welcome to another episode of Now, Next, and Beyond. I'm Jeff Nolan. Today, we're going to be talking about display manufacturing with Oliver Haupt, who leads the vertical market team for displays at Coherent. Oliver's a fascinating guy who knows more about display manufacturing than pretty much anybody you're going to talk with, and we're going to cover all of it. Now, I find displays to be absolutely fascinating because they are the primary way that we interact with the technology that accompanies our lives, from the smartphones in our hand to the computers we do our work on, televisions on our walls, our cars. Cars are increasingly a hotbed for display technology innovation. And this has been, this evolution has been long running since the 1960s when, punch cards were eclipsed with the very first cathode ray tubes. And then to an increasing innovations in not just the size and resolution and color density, but also then to move to flat panels, starting with liquid crystal displays, moving to LEDs, light emitting diodes, organic light emitting diodes, and now we're talking about micro LED and quantum dots and a whole lot more. Well, we're going to cover that today, what it means, how they're made, and what the future trends will bring us, not just as users of these devices, but as an industry that is responsible for delivering the technology necessary to build them. Thank you for joining us. Let's get on with it. Okay, welcome everyone. We're here to talk about display manufacturing with Oliver Haupt, who's our vertical market leader for that segment, which is a really interesting one. We've got a lot to talk about today, and I am sure you will be just as fascinated in this as I am. So, Oliver, before we start with the hard questions, let's take some easy ones. What gets you excited about your job each and every day?
Yeah. Hey, good morning, Jeff. That's a great question. So really to see every day new technologies coming up. So always state of the art and beyond, and talking to the customers while see new applications coming in. So that's keeping me at the work every day and exciting me.
And it's constantly changing, isn't it? I mean, there isn't a CES that goes by without some breakthrough new display technology that we're talking about.
Yes, yeah, it's great. Yeah.
How did you end up leading the display vertical at Coherent?
So it came that I worked in the business unit where we are producing a lot of laser and laser systems that are used to produce the displays. And then I'm ended up to be the vertical leader for all these processes within Coherent. So it's a great opportunity and a lot of great work.
So it's probably pretty fair to say that you know as much about the global display manufacturing capacity as well as the state of the art and who's buying what from where as anybody that I could ever hope to talk to.
Yes. That's true. Yeah, that's good. Yeah. Almost.
And let me ask you this. When you look at a smartphone, a TV, a device of any kind that has a display, when you get in a car, it's like, can you ever look at a computer display the same way again? I mean, you must just see every detail about it and know. And yeah. I can only imagine what goes through your brain when you're looking at a smartphone.
Yeah, exactly. So it's I'm seeing the screen and know our technology is inside the display. I know that a small camera hole is made by our lasers as well. So it's for me it's more than just a mobile phone or smartphone. Yeah, that's great.
So let's go into some more serious questions, and I'm going to ask an elephant in the room question here, which is relatively recent news, which is micro LED. We've been hearing a lot about that, and what we heard from Apple, I don't know, maybe a month ago, maybe a little more than a month ago. Did they just kill the micro LED industry?
So yeah, that was the big news a month ago and the big question. And it was a shocking news for some. Some are in the display supply chain and we talked about a lot. So the clear answer from my perspective is no, they didn't kill it. There are still a lot of companies and working on. So this week here at Display Week, you see a lot of micro LED displays already. And so it's no, definitely not. some companies decided also to quit their programs. But as always, like the display makers are really the one making good displays. They know how to do it, and they will continue for sure.
Okay. So while it's shocking to the industry, the fact that they not only killed that watch project, but then laid off the entire team, basically said, we're not even going to keep the people. That just is a blip. Other manufacturers are going forward.
Yes. And so let me say that's not about the micro LED itself. It's the way how to set up the supply chain. So for good reason, the display makers are making the state of the art high resolution displays, which we found in our smartphones, for example. And the goal setting up a new supply chain independent from display makers, I think that was a big mistake.
Okay. So let's talk about the competing display technologies that are out there, because we're going to come back to micro LED and go a little deeper on that. But let's start at a high level, because I get lost with the acronym soup here. We have LED, we have OLED, we have micro LED, now we have micro OLED, QLED, QDEL, and then there's AR and VR, which is a whole separate category of displays. Transparent displays. Help us sort it out. How do we group these things together?
Oh wow, yeah, that's we can talk for an hour about this now, but we can I can sort it a little bit out for us and you. So it's so we have, of course, the different technologies are there are main different technologies like LCD, OLED, LED displays. So this is the one main group, and also the process chains or supply chains are a little bit different. And then we group it, of course, in the from the size of the display, because also this is determining the process chain. So we have the very small, but saying always AR, VR in one context. For me, these are completely two different approaches from the display side, for example. And then we have the small ones like watch, mobile phones, and then going to larger formats like tablets and laptops is a category we call IT panel. And then we have the TV. And even in the TV, we have so many different technologies. Each consumer electronics company had their own display technology, which they are promoting.
Okay. So we're going to talk about things like quantum bits and OLED and micro LED later. But if we, again, at a very high level, are the manufacturing processes for these display technologies all pretty consistent?
Yes. So the one thing is when you start to make a display, you need somehow a backplane to drive whatever comes on top, right? So usually you have a glass plane, putting some conductive layer, and then if it's LCD or if it's driving LEDs or OLED material. So this is more or less constant. So the question is for the different products also, what kind of size or what is the size of the glass material you can produce? What are the following steps that you need to follow? So backplane is the start of the display. Okay. And these, and I've had the privilege of actually seeing the equipment that we ship. I mean, this stuff is huge, first of all. I mean, I was surprised at how big it is. I mean, it's like 3 school buses in size. And the entire process is done in a vacuum, right? Yes. There are a lot of or several steps done in vacuum, and you call our equipment, of course, 3 buses, size, but there are much larger equipment needed to make these large display panels happen. So, for example, the evaporator is a 100 to 150 meter long one equipment to make the colors on top. Wow, which explains some of the cost. So actually, that's actually a good segue because, this is like manufacturing nerd stuff right here. It's like, you're doing it in a vacuum. And I know there's a push. I mean, I know there's some of these technologies are developing to enable manufacturing at atmospheric pressure, which will dramatically affect the economics because clean rooms are expensive. The fabs themselves are big. And with each new generation of display technology,
being the winning technology or provider, it's like a license to print money, right? I mean, these things are hugely profitable, providing you can operate them at capacity with really flawless execution. Correct?
This is correct. Yes. Yeah.
And how long do manufacturers run these fabs? Well, how long do they plan on running them once they, commit the resources to building them?
Oh, good question. So when you look into the equipment, our first equipment was sold already 20 years ago, right? And it's still up and running. So the LCD fabs we equip with our equipment are still running to produce good or high resolution LCD displays. So it's really a long life fab done for producing displays. And as I said, some process steps are needed for even for the one technology and for the newer. So you can switch or change existing fabs or equipment also to newer display technology.
Oh, you can upgrade them. Yeah. Oh,
yeah.
Okay. Good. Mm-hmm. All right. So for let's say I have an idea for a new display technology. I've been working on it in my garage. I'm going to unleash it on the world. Okay. So we have brightness, durability, resolution, cost, and color density or tunability. Those to me are like the 5 factors that declares a winner in a display category. Is that accurate, or are there other factors?
Oh, that's correct. And and the most of the time, so we are, or not we, but our customers are producing for the end consumer market. So of course it's all driven about price. Yeah. So you want to have a high resolution TV at home, but the question is how much money you want to pay for it.
Yeah. Well, and durability is the other one, right? So, so let's look at this from another perspective. As a typical consumer, like you've got 5 things, like what are the 3 that I'm going to make a decision on, right? Well, screen brightness is a big one, right? If the screen isn't bright and it's not clear, I'm not going to buy it. I don't care how much it costs. So resolution. Durability is a funny one because I don't think anyone would argue that the typical smartphone display is durable when you can drop and break it, but durability is measured through different dimensions, right? I mean, durability from a manufacturer standpoint is more than just can you break it. I mean, the thing's made out of glass. Of course it's going to break, right? It has to sustain weather, environmental conditions. It has to last over time, right? They can't crap out before the battery does.
Yeah, but exactly, this is a question on what kind of application we are looking to, right? So if you have your TV at home for forever, and there's also a good question. So when you go to the show and you see how display makers want to compare different technologies. So if you put an ugly display next to the other one is more bright, more colorful, of course. But if you have your screen at home, how can you compare that there's a better one outside? So it's exactly. So this is interesting. So and I think that on the mobile phone side, it's of course it's the new screen, but there are also other features like under panel cameras coming up, or the features inside the phone that brings you every 2 years to the shop to buy a new one.
Yeah. Well, which I'm going through right now because my battery is dying like every 4 hours and I need to get a new one.
Yeah. So we are helping with our technologies to increase battery lifetime.
Well, power supply is a big one. Thermal and power. We're going to actually talk about that too. All right. So OLED. So optical light emitting diode, organic light emitting diodes. This is the winner right now. I mean, speaking of Apple, we talked about Apple at the very top, right? They just released new iPads and everyone is talking about how gorgeous these displays are. Yeah.
So, for me, working in this display industry, I have to watch the new outcome of these iPad last week, and it was amazing to see how they make the commercial. So it was all about the display. Yeah. And at the end, they talked about, there's also a new chip inside, but they called it the best display they ever produced. It was a breakthrough tandem OLED technology. First time they are bringing into this device. It's a brightness, color, contrast. So all the best only about the display. And then also it's the thinnest product they ever made. right? And this is also one advantage of OLED displays, that they can be very thin.
I found it's funny though, because the marketing on it was like, yeah, the thinnest iPad we've ever made. And I found myself like, I don't think I've ever seriously said to myself, I wish this iPad was thinner. It was like, but yeah. I get your point. It's the display itself helps drive that, which in a way, offers a downstream impact, because when your display is using less real estate or volume, that gives you more space for the other things that increase the capabilities of the device. So display thickness actually really does matter.
Exactly. And every micrometer counts in thickness. So
crazy to think
it's a lot of laser technology helping to make the high brightness thin OLED displays.
So the OLED manufacturing world is going through a big change from what's called Gen 7 to Gen 8. Tell us a little bit about what that means.
Jeff, sorry to say, Gen 7 is not existing. So we are moving from Gen 6 to Gen 8, and though it's called Gen 8.6. So this is good for us that the entire industry has some standards. So they are going from Gen 6. Now the next would be Gen 8.7. And so the largest one are made on Gen 10 for TVs. But now for OLED, the high sophisticated production, it's moving now from Gen 6 to Gen 8, yes. And this is a big step for the entire industry.
Yeah, well, what's the advantage of Gen 8.6? What's the big selling point on it?
Yeah, so the fabs, so building up a fab is quite expensive. A lot of capex needed, and the hope and the idea is to that the equipment and the total fab equipment is not much more compared to a Gen 6 fab. So, but let's say then if the Gen 8, which is a 2,600 by 2,500 millimeter panel, you almost can have, for example, double the iPad displays on one panel compared to the Gen 6 panel. So that means, it's a more economical way to produce the displays on the larger sheet, by almost using the same or only a little more capex to make it happen.
So bigger or cheaper? Is it both?
Yeah, it's both. So it's at the end, the cost per display can go down.
Okay, so bigger is cheaper. Why is that?
Yeah, it's it's a more economic way to produce them, and this is the way the display industry followed the last year. So we started with a very small Gen 0.2 fabs, and step by step growing and maturity of equipment. So now we are ending up at Gen 0.8. So the scalability of all processes for almost same cost then is a more economically way.
Oh, okay. So you spend all this money to buy all your equipment and build a building and get it all set up. So you've got the building, you've got the equipment, and then you've got consumables, right? Every time you run these machines, you're wearing them down a little bit. You need to replace stuff. And then you have the raw materials, the amorphous silicon panels that need to get annealed, and then all the other stuff that needs to happen. So what you're saying is that the cost of an individual panel actually is more dependent on all of the things that are independent of the raw materials. The bigger the panel, the more displays you can cut, which drives down your overall unit cost.
Yeah, exactly. So I'll give you an example on the Gen 6 now, that you say like the mobile phone or the IT panel has 4 times the area of a mobile phone. Yeah. And it's known that a good OLED display today in a mobile phone is about $60 to $80. Yeah. So if you go to 4 times the area, so how can that work out? So if you pay only $300 for $320 for one display, where should the entire iPad ending up? So you have to be more economically way and by scaling up, you can reduce the cost per device.
Do I get a bigger TV too?
A bigger TV?
Yeah. Can I get a bigger TV out of Gen 8, or is that all Gen 10?
This is the most out of Gen 10. So this is a different technology. So more simple processes. So of course there are big TVs already, but you can make them almost. Yeah, we have seen already you can make walls. But this is another technology we'll talk in a minute.
Well, and we actually do have we have an 83-inch OLED TV in our house, and it is a phenomenal. And I remember when I was shopping for it, I'm like, oh my God, these things are so expensive. And then I'm like, just don't tell my wife. Don't tell her how much I paid for it. But it is a phenomenal. But it's really remarkable is how when you go up beyond 83 inches, the price, it's like quadruples. It's no longer, it's no longer viable for a home buyer like me. Mm-hmm. Okay. I actually want to, while we're staying on manufacturing, quickly walk us through the process that needs to happen in order to go from raw materials to a finished display.
Wow, yeah. As I said, it's if you see a display fab, they are almost a kilometer long. It's a very high, tall building. So there are a lot of steps. But the good thing, it's a really mature technology. I said so when I have enough money, I can build up a fab. So I not just need $7 million today. I know exactly what I need from the equipment. So you need the glass, goes into the fab. And then one of the first steps is evaporating an amorphous silicon that needs to be annealed to make a good smartphone. So then our systems are coming in the first time. And then going to all these layers. So they are evaporated in these huge evaporators, which are 100, 150, maybe 200 meters. So there are a lot of vacuum, very big vacuum chambers to make all these colors and circuits happen. So, and then once you have your display, so you have the big large panel ready with all the OLED on top and the encapsulation, everything is ready. And then you need to cut it into pieces, right? So, and the decision or the question is it a flexible display or a non-flexible? So if it's a flexible, you have to peel off the entire large, let's say, plastic foil from the glass. So you waste the glass away or reuse it. And then you have to cut these big foil into small pieces. And this is done by lasers as well. That could be done in a different fab. And so after then you have to cut it into pieces. Then you have to glue cover glass, and then you have all your mobile phone electronics and to combine it.
How long does that process take from beginning to end?
It's I think our step is a few minutes. So it's to running to the entire fab is. I don't know exactly, but it's in a half an hour or 15 half an hour.
It's pretty fast. considering the volume.
So making. So for us, it's always very easy because the fabs are also built in a standard. So you have a certain capacity for a fab, and this is also amazing when you see they are talking in thousands of sheets per month. So how many of these they can produce? So, and this is very great to see. It's really a manufacturing process.
So the annealing process is particularly interesting to me because so you take this amorphous silicon sheet and then you change the molecular structure of it by heating it up. Why can't it just come like that from the supplier?
Because so it's a necessary step when you want to make a high brilliant and high resolution display. So this is all about called electron mobility. So to drive the display, you need for higher resolution, you need a higher mobility. So amorphous silicon itself has a very low mobility, which is good for TV sizes. But if you go into mobile, you have to change the crystal structure to polycrystalline.
Is that also why on my computer monitor, which is a pretty nice computer monitor, the display does not have that crystal clearness that my smartphone has?
Up to now, this is one of the reasons. It's good enough, and also it's all about pricing, of course, but with the latest announcement about the iPads, and there's already the roadmap also to adopt it to laptop formats. So IT, what we call all IT panels.
Okay, so we use excimer gas lasers and for this in this process. I mean, obviously, it's more than just lasers. It's a whole assembly and system that's designed to use it. But the laser is an excimer gas laser.
Yes.
We pioneered a new solid state laser, a diode based laser for this. And what's the industry reaction been to that?
So that's right. So gas lasers are very common also in semiconductor industry, but now also in the entire display industry. But when you hear so we are listening careful to our customers, they always saying, oh yeah, there's some level of maintenance necessary, but they want to have this superior quality out of our lasers and our optical systems. Yeah. And this comes with the laser we developed and enhanced for the last 20 years. So today we can state all displays are made with these kind of lasers and our optical systems. But of course, the cost of operation also one factor. Once the fab is set up, and as I said, they can stay for 10, 15, and 20 years. So the cost of operation are also coming into account. And therefore, we developed, this new laser. So DPSS, diode pumped solid state lasers, are known to have a longer service intervals. So they should have or come with lower cost of operation. So this is our newest development and offer for the industry. And we see a lot of interest, but we see that customers are also very conservative. So today a fab will build up in China in 18 months. So they have to say all the equipment goes in and then they have to produce panels. So they cannot take any risk. So even if we have the laser designed, they having the same properties like the other one. So we have a good offer and we can leave it to the customer which way they want to go on the long term.
Okay. So there's this whole process continuity. So just because you have a different laser, that may impact gas deposition. That could affect a different process step down the way.
So usually the thing is we are, as I said in the beginning, we are working on the backplane, which is the foundation of a good display. So whatever we changes have in the first layer affects maybe the yield and the quality of the entire display at the end.
Okay.
So and therefore we need to provide a very constant, high quality, 24/7 mass production system that always delivers the same quality. And this is what our system's doing today. And we are working on with a new technology that this is also for the future.
Meanwhile, excimer remains, the attributes of excimer remain ideally suited for this best in class, right?
Yes.
Okay. So basically OLED's going to be around for a long time. All the fabs that are being now superseded by the Gen 8 fabs, they're still going to be operating, right? Because there's no reason to shut any of these fabs down.
No, that's correct.
Okay.
And even by the way that when we talk about the mobile phone, our feeling is that every mobile phone is already equipped with a OLED display. So if you look to the entire market of the 1.3 billion smartphones that are shipped and sold every year, it's approximately 50% of these are only equipped with OLED. So there's also a good portion or remaining opportunity to change to OLED displays.
Okay, so let's talk about what's beyond OLED, because there's always something new, right? We talked about the acronym too. Quantum dots. They've got a lot of attention lately. What are quantum dots?
So these are to explain it very easy, these are nanocrystals put on top of a driver, and they can also emit in a very precise way in red, green, or blue. So it's like emitting the color, and quantum dots. Even here at the SID this week, so we see a lot of quantum dot displays for larger formats. Yeah, and they are really also bright.
So they're the quantum dots. They're the light source. They don't need a backlight.
They don't need so they just so no
Yeah.
they need they need a backlight and so needing a white OLED or LED backlight to excite the light. So this is indirect emissive, what we call it. Well, OLED is a direct emissive.
Okay, so all of these technologies that have an O in them rely on organic compounds that degrade over time. They burn in, right? And
Yes.
Does this characteristic or unintended consequence become less of an issue over time, or is this just inevitable?
So at the moment, so all these new products coming out are for say monitors and TV, which has to stay for a long time. So and like in the TV. So the leading technology beside the old LCD is OLED TVs at the moment, and so the lifetime is, let's say, it's good enough for this kind of products. And what I said in the beginning, you don't see the aging at home if you not have a new comparable TV next to it.
Now Next and Beyond is hosted by Jeff Nolan, produced by Carly Bergall, and presented by Coherent.